Okay, Squeeze theorem for sequences. So this is also true for functions, right? If you have a, remember we had a function, right? If you had a function, let's say f at x, and it was always greater than or equal to, let's say, h at x, but always smaller than or equal to g at x, and if the g at x approached L, right, and h at x approached L as x approaches infinity, then by Squeeze theorem we had to say that the f at x also approached L. This is saying the exact same thing. Okay, it's saying the exact same thing. Alright, so he says here, if that's approaching the an as well as cn is approaching L, then the one in the middle, the one that's squeezed between the two, also has to approach L. Okay, so here's a very interesting example. An is n factorial divided by n to the power of n. Is this converging or diverging? Okay, I hope recall that n factorial means, you know, n times n minus 1 times all the way to 1. Okay, so an, let's first break this down a little bit more. So let me write n factorial in the expanded form, n times n minus 1 times n minus 2 times, okay, all the way to, let's say, 3 times 2 times 1. N to the power of n just means for every factor there's a matching n right below it. Okay. Okay. One thing we know for sure, an, right, no matter what n is, an is, because all the numbers of n are positive, an is greater than, okay, it's greater than 0. Okay, it can't equal to 0, but it's definitely greater than 0 always. Now let's consider this part of the expansion, just that part. And this part considered separately, okay? Now ask yourself, this square box that I highlighted, is that greater than 1 or less than 1? Okay, so to answer that question, you have to look at the numerator and the denominator and see which one is bigger. Here it's same. Here this is 1 smaller than this, 2 smaller than this, 3 smaller than this. So clearly the numerator is smaller than the denominator, right? Which means this part here is less than 1. Okay. What that means is that this whole thing, this whole expression here is less than 1 over n, right? Because what we have here, right, what we have here is k times 1 over n, where k is less than 1. So it's going to make 1 over n smaller than what it originally started with. Okay, so now we have the condition then, from that, the an is actually less than 1 over n. Okay, now let's make n approach infinity. You can see the left side is approaching 0 and the right side is approaching 0. So by Squeeze theorem, an also must be approaching 0. Okay, so we simplified a very complicated looking expression using Squeeze theorem and found the limit.